So just a short background on our company, Omega Seiki Mobility. We are a part of Anglian Omega, which has been in business for last 52 years in India in steel and automotive businesses. Our electric vehicle business was started in 2018. We started looking around at it around 2015. And 2020, in the auto show, we launched our first vehicle. This is the electric three-wheeler L5 cargo version. And this year in the auto show in Mumbai, we launched our refrigerated version on a L5 platform. So this is the first one, reefer vehicle, which is targeted at pharma, vaccine, and other perishable commodities transportation. Apart from that, we've also launched our two-wheeler scooters, then our passenger vehicle in the L5 and L3 category. And we are working on new products, which would be on road in the next few months. So the product pipeline you could see is quite good. And we are looking at a complete mobility solution from two-wheeler, three-wheeler, and four-wheeler. The four-wheeler truck was showcased at an event a few weeks ago in Delhi. So that's what we are. We are a 100% electric vehicle dedicated to electric mobility in India. And we work with many, the battery makers and powertrain makers in the whole ecosystem. So I'll just start my, presentation on the battery. What are the capacities globally? As we know, lithium-ion battery has been by far the most successful technology in the space of electric mobility, and it has been growing, exponentially with the investments that are going into it. By rough data shows, more than $400 billion of investment has gone into adding capacities in the last couple of years alone. So today the situation is in Asia Pacific, which is led by China. The capacity is around 370 gigawatt hours. China, obviously the leader here, and Europe has 60 gigawatt hour, and globally we have around 470 gigawatt hours of capacity. However, due to the exponential rise of electric mobility globally, several battery makers are investing heavily and adding capacities. A lot of OEMs are creating their own dedicated capacities, like in the US and Europe. So there are already more than 100 gigafactories in the pipeline for construction globally. And by 2030, which is not really too far, the lithium-ion battery capacity will be up 7 times from 2020. So we're going to have close to about 3,000 gigawatt hours. And in the context of India, as we know, government is already come out with the PLI schemes and other incentives for creation of advanced cell chemistry in India. So India will also have a piece of it. Now coming to the, the various materials that go into it, and particularly the lithium, cobalt, manganese in various chemistries, and these are the 3 vital metals for lithium-ion batteries. They are also highly energy intensive and environment impacting industries globally, as we know. And the picture says it all. You could see the way the mining is done, the huge amount of water consumption that goes into lithium extraction, mining, etc., is humongous. There are various data available, but it talks about something like 400 to $2 million liters per kilogram of lithium. And lithium reserves are centered around Argentina, Bolivia, and Chile, where most of the mining happens by companies from China. China obviously controls a majority of these mining and extraction. Now, another important point in the whole value chain is the refining capacity. Today, as this slide shows, I've taken it from the Bloomberg, one of the paper. Almost 90% of the mining happens in China. and see the amount of travel that these materials will have to do, all the way from Latin America and Africa to reach China and then back again for to be used in the automotive industry. By an estimate, around 50,000 miles describe the route by land and sea that some materials travel before reaching the car manufacturers as finished battery cells. So this is a huge supply chain that needs to be put in place if a company or an organization wants to get into battery manufacturing. Now this is important in the context of India, because now Indian government is promoting the cell manufacturing, and instead of remaining import dependent, so they have come out with the advanced cell chemistry PLI scheme, etc. Now the point here is that unless the refining of these crucial materials happens in India, probably we will remain import dependent up to a large extent. Now here, I would think companies like Reliance, something which is analogous with their, which has an analogy with their petroleum refinery. They created the world's biggest refinery in Jamnagar. So somebody like Reliance probably needs to get into this refining as well to make India completely independent battery cell manufacturing country. We'll have to see how it pans out. Now, lithium-ion battery cell suppliers by quality and volumes, as we know, the cells are generally categorized A, B, and C category depending on their, the quality of charge, holding charge, discharge, etc. In the top, the big names are Tesla, Panasonic, Samsung, and bottom two, the tier 2 and tier 3 are, most of them, as you can see in the graph, are Chinese companies. So this is another issue that is relevant in the context of Indian EV industry, that almost all the cells are coming from China, and we have no system to really check whether this is A grade, B grade, or C grade cell. And many of them have led to serious accidents and safety issues, etc. So here again, we need to be very careful on the kind of supply chain that we have in place. Now, in this background, I would like to come to the key concerns that vehicle makers have, and what the battery makers as our partners need to address the challenges. These are, currently the current density, charge density is currently 10 kilometer per kilowatt hour, or around 85 watt hours per kg. So the battery tends to be very heavy, and also the kilometers that we get is relatively low. I am told, I was talking to a friend of mine in the US yesterday, and he told me that in lithium-ion packs, the kind of charge density that they are currently doing is above 200 watt hours per kilo. So this is roughly somewhere around 1.5 to 2 times of what we have it here. So this is something that we need to develop, and the technology to pack in more charge in the same kilogram of the battery. The charging time, as we particularly important in the context of commercial vehicles like 3-wheelers and the pickup trucks, etc., is the downtime that is required for battery charging. So if you have 4 hours or 5 hours of downtime, obviously it eats into your revenue. So now there are technologies which are evolving fast, the rapid charging, quick charging, etc. So it is linked very much to the health of the battery, whether it is able to take that kind of charge, quick charging, 2C, 3C, or whatever, and the thermal management and the life of the battery which is associated with has to be compatible with what is the charging time that we are talking about. Now, as the industry evolves, the new technologies will be coming in, and I'm pretty sure that this will be one of the major issues to be tackled with. Safety, Dr. Sampath and Venkat talked a lot. I will not touch more, but I think the thermal management in the context of a vehicle is the most important point to be taken care of. And it is actually a very serious issue that we have seen in recent cases of fire and other safety hazards. So I think there has to be a system to guarantee the thermal management. And also there are a lot of low end cheap imported batteries and cells which are landing here. So unlike people, I mean, this is an opportunistic business model adopted by certain entrepreneurs. I don't want to debate on that, that's their business. But you got to be careful here in terms of the playing with the lives of the people. And the way the battery is put in the vehicle, the way it is charged, or the connectors, those are used, the charger which is used, all that has to be compatible. And as per the design, that has to be, obviously the foolproofing and etc. also has to be ensured by makers like us. But we also have to be very, very careful on using the right materials and the chemistry that goes into the battery. So unlike solar, where even cheap materials probably could work because it's a stationary application, vehicle undergoes a lot of stresses. There are a lot of such static, dynamic, thermal stresses on the vehicle. So we need to be very, very careful on that. Cost, obviously, end of the day, it has to make economic sense when we develop a vehicle. So today we are at a level of around $225 per kilowatt hours. I mean, there are various speculations in the market talking about below $100 and all. But again, as we have seen, the cycle of commodity prices are very much on the up cycle today, and also coupled with the availability, there I mean, today there is a shortage of chips and ships, as we say, so the logistics costs are also hitting the industry badly. But I am sure, once the with the right technology and the scale, I think the economic challenge can be overcome. I am of the firmly of the view that okay, cost is a problem, but cost is not the only problem. We got to use the technology to solve the problem. And again, the battery life, currently the makers are giving 1800 to 2000 cycles in LFP, and the FAME 2 also mandates around 1800. But I think the industry needs to go much, much beyond that. I'm told in China, typical levels are around 5,000 cycles, which is great. And I think we need to be, talking on the same levels. Then obviously the material supply chain, I have shown you, most of these materials are not available in India. And also again, the biggest question is the refining and accessing those materials is a problem, is a challenge that, the industry has to handle, manage, set up robust supply chains so that materials are available for manufacturing in India. Again, and this has led to the cell manufacturing in India as of now. Only the packs are manufactured. So these are the challenges which I thought are relevant for the automotive industry in India. Now, what are the desired solutions? I think EV batteries need to get the desired levels in terms of charge density. Ideally, we should get over the the range anxiety, as it is called, and maybe 200 kilometer on a single charge, whatever chemistry that we use or we evolve, and whatever configuration that we get. It is not, and please understand that this is not the job of only the battery maker or battery producer. It is the complete vehicle integration that I'm talking about. The vehicle manufacturer has to work with the battery supplier, the powertrain supplier, and do the grounds up engineering here to reach these desired levels, so that we have 200 kilometer on a single charging time less than 1 hour. Obviously, this is the ideal situation. And then the most important thing is the BMS, the role. The BMS has to ensure there is the cell balancing and communication. Obviously, safety, we have emphasized again and again, no overheating or thermal runaway. This is like a live bomb you're carrying in your vehicle. So we have to be very, very mindful on that. and cost ideally probably the economics for less than 150 US dollars per kilowatt hour. But again, as I said, this is not the only factor. Battery life over 5,000 cycles would be great if we have for the automotive use, and we are talking about typical vehicle life of around 7 years or so that commercial vehicle undergoes in India. So looking at the usage pattern, etc. So I think this would be great that we have around 5,000 cycles. Again, we need to look at alternate materials for cathode, electrolyte, and separators. And this is where I think the other stakeholders from academia, researchers, etc., have to come together along with the industry and work out a solution, because unlike in many countries in Europe and US, this kind of interaction in India is very little, and particularly in the IC engine, we haven't really seen, much of the knowledge getting transferred from academics or researchers into the industry. I think so. This is a great chance. I think this is a very good opportunity, and I'm very happy to see IIT Madras, for example, doing a great job in the incubation of various technologies like new generation motors, highly efficient motors using alternate materials, etc. So this is where I think we need to come together along with other partners. So battery manufacturing, cell manufacturing in India with a robust supply chain of all materials, as I said, it will be the ideal situation. If we have access to materials, then we have the refining, and then we get into cell manufacturing and eventually the battery packs. Obviously, robust supply chains like this develop over several years, maybe even decades, to have a very kind of robust supply chain where where the materials could be accessed at, and also the question of ethical mining and environmentally sustainable material extraction, etc., comes into play. So we'll have to see how it pans out, and the big companies, big business groups like Reliance, Adani's, Tata's, etc., I think will have to play a role here along with government. Now, battery solutions, I would like to talk about is that, sorry. Yeah, sorry. Joint development of battery solution with the battery makers. So as I said, it is not just the battery manufacturer. Today what is happening is the industry, okay, it is still evolving. These are initial days, early days, but the concept seems to be, take an IC engine, take out the engine and the gearbox, and put back the battery and a motor, and you have a ready-made EV. I think this concept has to change, and particularly with four-wheelers and other higher form factors coming into play. So you need to design the vehicle around the battery system. That is how the modern vehicles and cars are designed. You have not just a compartment for where you could put the battery, but the whole vehicle architecture is designed around the battery system. So the whole battery, the cooling, the BMS, and the whole wiring harness, etc., has to be designed accordingly to have the best, efficient and optimized design. So we have to work, OEMs have to work together with the energy solution providers to solve these issues, and the selection of the chemistry, what is the chemistry, whether LFP, NMC, even graphene is coming into, then electrodes are undergoing a lot of changes. We're talking about sodium and silicon and so on and so forth. So, we need to get into the right selection where we have the availability of the material in place and the whole supply chain is in place. And then obviously, end of the day, it has to make the economic sense to all the players in the supply chain. Then battery testing, validation, and standardization is very important. You see, the problem, and I have highlighted this in meetings with certain government agencies as well, that today, there are no standardizations. We don't even, we can't even check. No agency, even ICAT or ARI, is able to check whether this is a grade, B grade, C grade cell, and what kind of standardized battery pack is required to fit into the vehicle, where we could say, yes, this is guaranteed against all the thermal issues or fires or other safety issues. So I think that needs to come. Okay, IP65, IP67, etc. is there, but a vehicle needs more than that. We need to be able to ensure throughout the life of the vehicle, in terms of the battery performance, usage, the throughout the life cycle of that. So as we call the complete life cycle management, or cradle to grave, concept. So I think there a lot of work needs to be done again by various agencies, government, academics, industry, and come up with the standardized design of batteries, connectors, and protocols have to be put in place. End of life handling, obviously, I think the OEMs will have to play a role here, and to be able to track the vehicle right from the day it is out of the factory to the day it is ready to be recycled. So I think a lot of debate has started in this direction. Government also came up with a end of life vehicle scrappage policy, etc. So, of course, in EV, we are still not there, but very soon, I think we need to plan this so that, once the vehicles are reaching the end of life, we should not be caught, unprepared. And my view is that, of course, it's a very complex technology to extract the materials, and it calls for a lot of investments. And I think, again, some joint effort has to be done in this area as well. So end of the day, I think the battery economics need to make sense, and the way it could be done is by using the technology, having multiple stakeholders on board, battery makers, researchers, the BMS manufacturers, and the OEM. I think this is the way we would be able to have a stable engineering design for for any form factor, whether it is two-wheeler, three-wheeler, or four-wheeler, and we would be able to ensure that a robust design is in place. So I would leave the forum open for questioning, etc. End of the session, and we're very happy to answer anything on this. Thank you very much, Priyakshu.